Hey everyone, good morning and good evening. Let's start with today's session and let's see what exactly we're doing today. Okay, so guys, we are starting with a new topic that is Docker today. So let's do a quick reiteration what we did till now. Last session we did how do we integrate Ansible with Azure DevOps, and we saw how do we run Terraform using Azure, Terraform using Linux Ubuntu OS. That is what we have seen till now. Okay. Now, okay, let me quickly share my screen if I'm not sharing. Today, we'll start with Docker. Now, what is Docker and why do we need Docker and why this tool is important for us to learn? That is something we need to understand. Okay. Now, why this tool is important to learn? Because we are moving into the microservice world wherein we are creating microservice applications. Okay, we are moving from legacy monolithic to microservice application. Okay, what do I mean by microservice? Can someone explain what do we know about what is microservice application? Anyone wants to share something? What do you understand by microservice application?
Um, I think that refers to when you have a couple of services that are decoupled,
Mm-hmm.
but also communicate with each other.
Perfect. Anyone else wants to add something to it? Okay, no problem. Very good. So yeah, a bigger application gets decoupled into small services, but they are loosely coupled with each other. Okay, they're connected with each other, but all these application modules are built, developed individually. So for example, think of a Amazon.com. It's a big shopping website, correct? So just think of your shopping cart module, your authentication module, your payment gateway module, your product module. All these are developed individually. They are deployed individually. They have their own databases. They have their own configuration. They are not dependent on any other modules in your application. If something happens to any of the module, that part is affected, not the entire application. If you're making any changes to one part, then only that part is impacted. Okay, but they are loosely coupled. When I say loosely coupled, they can easily communicate with other modules. That is what microservice in a very short. Okay. On the other hand, the legacy application, the monolithic application is like a big ball, a giant ball, where everything is clubbed together and that is tightly coupled together. If you're touching one part of it, there is a great chance that it may impact the other part of the module also. So that is what monolithic means. So as we are moving, we have already moved to microservice world. People started all the new application, whatever they're building into microservice. Whatever legacy application they are migrating to the microservice world. Now when you move to microservice world, when you have so many services running, it is quite impossible to have VMs created for all this. I'm not denying that you cannot create VMs. You can definitely create VMs, but it is not cost effective, correct? Plus it is because if you create a VM, like suppose imagine you want to create a Windows VM, the minimum requirement for Windows VM will be somewhere around 4 CPU and around 8 GB of RAM. Why 8 GB? Because 3.5 GB will be taken by the Windows OS itself. Correct? Agree everyone? And on top of it, so this is, and at least you will need 128 GB of hard drive in it. That is the minimum requirement what you will have with VM. And just imagine if you're deploying something like Amazon, imagine the amount of VM you will require to put all your modules in place. all your services in place, which is not cost effective. Definitely not cost effective because you'll end up paying much for the hardware. Okay. Then coming back, then this gave rise to something called containers. Now, what is containers? Containers are nothing but, guys, these are lightweight boxes. When I say lightweight, what do I mean by lightweight? The same thing, like just take an example of Windows. Now in the Windows, how much config you took? 8 GB of RAM and 4 vCPU. Okay, and around 128 GB of space. So in such a big, you can have around 10 containers running. That is what lightweight I'm talking about. Okay, when I say 10 containers, so why this is so customizable, why Docker is so customizable, why containers are customizable, that I can launch 10, 20 containers on that config. The reason is the image what we use over here. It's lightweight image what we use. Like suppose in Windows, if the image size is of 4 GB, in inside a container, the image size will be somewhere around 300 to 400 MB. What do I mean by that? Why it is so less? The reason is very straightforward, because when you boot a Windows system, okay, you get so many extra things, like you get the calculator, the calendar, the GUI, the many things you get. Okay, so all these extra add-ons which you have in your OS, when you launch a container with a Windows image, all these extra things are removed. Only those things are there inside the image which will help you to run your services. That's it. Same goes with the Ubuntu machine also, Linux machine also. It's hardly 300 400 MB files, frankly speaking. So that will contain only those things which requires which will be required for running your services. That's it. Nothing else is required. So that is what images is. That is why containers are lightweight, guys. So that is something we'll talk about in details. So there are many container services. Okay. One of the very known container services which you will come across is Docker. Okay. There are others also. There are Container D. There is a Kubernetes Archlet. Kubernetes also has its own container service. So there are many container service, but one of the very famous open source container service is Docker. Okay. Now, what is Docker? Why do we need Docker? Let's go and see that. Okay. So why do we need Docker? That is the biggest question which we have answered for microservice application deployment. Okay. Now, as I was saying about the VM, okay. So this is how the VM works. You will have your underlying hardware. You will have your compute, you get your CPU, memory, and everything. So this VM, just imagine this is created on your cloud. Just take any cloud infra, AWS, Azure, GCP. You have created a VM. On top of your hardware, whatever compute you have selected, you got your OS installed. So take it as a Ubuntu OS, a Linux OS, and then you got all your libraries and dependencies. Okay. On top of it, now you have deployed your application. So you're using Apache web server. Imagine. Then you got MongoDB. Then you got Reddish. So this is a three-tier application what we have, which is wherein we have this Apache as a web server, and we got MongoDB as a database, and Redis as a middleware. Okay, wherein we are doing the caching and everything. So this is a typical example of a three-tier application which is deployed on a VM. This is on a hardware. This is one VM what we have deployed. Now, what is the issue faced with these VMs? Now, there's no issue as of now. While doing the setup, everything is looking good. Now, imagine there is some dependency upgrade for Apache, and there are some dependency upgrade for Reddish cache. Okay, there are version changes, suppose in future. What do? You go and upgrade your Apache. And because if Apache got upgraded, there is a great chance that your other things are also impacted, because everything is installed on the same machine and there are compatibility and dependency issues along with them. That's the biggest issue which we were facing before. Now, if MongoDB is getting upgraded, then other services getting impacted, because they are sharing the same drive, they're sharing the same library, they're sharing the same dependencies. Okay, because of which we are getting compatibility and dependency issues. Long setup time, yeah, because you're setting up the VM. On top of it, you're setting up all the dependencies, libraries, you're setting up each and every applications and things like that. So it's definitely takes a longer time to set up. Different dev, test, prod environments. So if you're setting up dev first, somehow your dev started working, you have taken care of everything. Now if you want to set up a different environment, you need to repeat the entire thing again. So this is where Docker plays a very important role. So this is a typical example of setting up something on a direct bare metal VM. This is what a typical example is. So what can we do with Docker? Now Docker is the same setup. It's the same VM. Okay, you got the hard drive. On the hard drive, you got your OS install, like your Ubuntu OS install. Now the difference is on the underlying OS, there's one more thing we have installed. We have installed Docker runtime engine on top of the OS. And the Docker runtime engine now has segregated everything. Now this Apache has its own library and dependency, and this is deployed inside a container. This is a container box. Your Apache is running separately, your MongoDB is running separately, your Redis is running separately. It has its own library, it has its own dependency. There is no interconnection between any of these. If you're making changes to these dependencies over here, there is no chance that others will get impacted. This is what Docker will do for you. It will containerize your application. It will run each service with its own dependency in a separate container. Okay, so this is completely isolated now. This is treated as one service container. This is treated as one container. This is treated as one container. Okay. Now this is all installed on the same VM which we were using previously. The only difference is now we got Docker runtime service running on that container, and we have containerized all the application using Docker and made sure that all this three-tier application is isolated. If we are making any changes to any of this part, then others are not impacted because of this. Okay. Now how Docker works then? So basically Docker uses the same kernel, underlying kernel. So they have their own library dependency, they have their own storage, and everything is they have their own services, they have their own processes. But one thing is common across all these containers, that is they are sharing the same underlying kernel of the OS. So in a way, when I say it is completely isolated, it is not truly completely isolated, guys, because they are using the same OS kernel for doing all this stuff. So in a true manner, if you ask me, in a true manner, it is not completely isolated. The kernel is getting utilized with all these containers. Kernel is what? The heart of the computer in Linux, correct? It manages, it is a middleware between the hardware and the processor services which is running. It is the one which is allocating all the memory, the compute to the respective processors. Correct, guys? Anyone has any doubt with the kernel? What is kernel and things like that? Okay, so that is what even kernel is managing the entire containers over here. Docker is just a service which is running which is making sure that the application are containerized, but it is using the underlying kernel. Okay, understanding containers. Okay, let's understand. This is how you got this OS kernel, you got this Docker running on top of it. Now they have their own. So these are containers basically. They got their own processes, they got their own network, they got their own mount. Mount is nothing but storage, but they are using the same underlying kernel. Okay. Now, in a true manner, if you want to know, I don't, so like suppose you got a requirement, no, we don't want to use the underlying kernel. I want each container to have its own kernel and things like that. So then in that case, you don't need Docker, guys. In that case, go and create VM. In a true manner, if you talk about isolation, then VM will be completely isolated. You can have three VMs created. One will have your Apache running, one will have your MongoDB running, one will have your Redis running. Then in that case, it is in a true manner, that is a proper isolation what you're doing. But that is not cost effective, correct? Imagine if you're launching three VMs of Linux. So at least Linux, you can have 2 vCPU and 4 GB of RAM and at least 64 GB of hard drive. That is the least you will provide to a Linux machine, correct? So imagine that those configuration into 3 and then calculate your cost. Because in this same configuration, in one VM, we can have everything containerized and we can have everything running smoothly. Okay. So Docker, if you get an interview that is it isolating your application, is it so? Yeah, so it is at the Docker level. Yeah, the application are getting containerized and it is getting isolated with each other, but in a true manner it is not isolated because it is using the same underlying OS kernel. All are sharing the OS kernel. Okay, just keep that in mind. Let's do a quick difference between a container and a virtual machine. So on the left hand side, what do you see? That's your virtual machine. This is your virtual machine, guys. So we got the hardware, your compute. So virtual machine, basically we use hypervisor if you're using VM. Okay, when you go and use VMs and all, so there is a software called hypervisor, which is providing you the breakup on the hardware. So the hypervisor is a tool which is basically uh, dividing the compute on the hard drive, okay, and giving you the VMs basically. So if you see, this is my one VM wherein it got its own OS. You got the application deployed. It has its own libraries and dependencies. Okay. And then this is the other VM wherein it got its own OS. Now on the right hand side, if you see, this is a Docker machine. Now you got your hard drive. On the hard drive, you got your OS install. Then on the top of OS, you got your Docker install, and this is how you will be containerizing your application. Okay. Now what is the benefit? Now if you see the utilization is very high. So you got multiple VMs created and both the VMs are getting used. So your utilization is very high over here in the VM. Wherein if you see the Docker, even though you got the same VM deployed over here, and on the top of it you just got Docker installed and you have both your application running on the same VM, though it is less utilized. It will take spaces in GB. If you're launching a VM, at least I said 64 GB or 128 GB of space which is required. Okay, so this will take spaces in GB, wherein if you have a Docker container, it will take spaces in MBs. That the boot up time, so getting your VM, a Windows VM to come up, it takes time, correct? The boot up time is high. Container, while running one command, within a second you will have that container up and running. So the boot up time is less. So this is a quick comparison between a container and a virtual machine. Understood, guys? Why do we need containers? Why containers are important nowadays and things like that. Anyone has any doubt? Anyone? No doubt? Okay. If no doubt, let's go and set up container, Docker, not container, Docker. Okay, so this was a quick glance. Why do we need Docker? Why do we need microservice application? Why can't we use VM and do isolation? So this is a quick example of why we need containerized application. Okay, let's go and do a quick setup. So what I'll do, I'll set up Docker on a Ubuntu machine. So we'll go and launch a Ubuntu machine, and on top of it, we'll have a Docker container running. And I'll show you how customized Docker is. So Docker is a window like Linux native application, guys. So whenever you use Docker, 101% of time you'll be using Linux as your VM. Okay. Now Docker starts even runs on Windows also. You can also enable virtualization in Windows, and if you want to run Docker on Windows, even that is possible nowadays. Just keep that in mind. Okay. But is it truly running on Windows? The answer is no. So on Windows, you enable your virtualization, and then you have a Linux image like Ubuntu image, which is installed on your system. And on top of it, you go and set up Docker. That is how Docker works on Windows. So in real manner, Docker will require Linux kernel. Okay. And on Windows, we don't have Linux kernel. As simple as that. So that is why we get Ubuntu and do many setup. Then we run Docker on Windows, guys. So if you see, even I have Docker on my machine. So, but this is running on Ubuntu. I got Ubuntu 18.04 on Windows. On top of it, I have Docker. So this is how I'm running Docker on it. So, but if you're using any such tools like Docker, Ansible, Kubernetes, these are not Windows native. So you have to have Linux machine for that. Okay, and when you go in company, they will not also use Windows for all this, guys. They will 101% they will use Linux machine for all this. So that's why I'm giving an example of Linux over here. Okay, what we'll do, we'll set up Docker. We'll go through the Docker basic ad hoc commands, like how do we work with Docker, how do we create, what is images, how do we see if the containers are running and things like that. So all this we'll see. Then we'll see how do we create a Docker file, what is the Docker file. Then we'll have, if you remember, we got a .NET application initially created for a CI/CD pipeline. That .NET application I'll deploy it on Docker. I'll show you how a microservice application gets deployed on Docker. Okay, makes sense? Anyone, any question? Got the VM running. Let's switch to root. Okay, let's set up Docker. These are the steps which we need to execute.
Why we need to run every time apt update?
So apt update is basically whenever you create a new VM. Okay, so there are local repositories which you have in your VM. Okay, so those may not be updated. So how the software gets downloaded, like what packages gets downloaded, that it connects to a remote repo. So your local repo, and plus it has a remote repo. So the remote repo keeps on updating. Like it has a big community. They keep on updating the remote repo, and your local repo is not updated. It's not up to date. Okay. So with this command apt update, what we are doing, we are updating, we're syncing the local repo and the remote repo, so that whatever packages you download after that by running the apt install command, those are up to date packages. If you don't run this apt update, there is a great chance that you may end up getting error whenever you try to install any packages. So it's always good practice, like whenever you're logging into a Ubuntu machine, or if you're downloading any packages, then running apt update. So apt update is nothing but it's just making sure your local repository is synced with the remote repositories. Okay, if you see this, this is all connecting to azure.archive ubuntu.com, and it is getting you all the packages.
A quick question.
Okay,
Quick question.
Okay, thanks.
no problem.
I have a quick question.
Yeah, tell me.
Is there a difference between apt get update and apt update?
Yeah, these are all utility tools like apt get update, apt update. There are others also, snap. These are all utility tools. Okay, so these are all different versions which was introduced, because these are all open source tools which we are talking about. So these are all utility depending upon what you're doing. So basically in Ubuntu, I'll suggest 90% of time use apt. apt get is a prior older version, so it has its own feature. Each tool has its own feature, its own capability. Depending upon your requirement, you can go and use what tool you want to use. But yeah, on the upper side, if you ask me, both all these are middleware package management tool. When I say middleware, this is because it's just a package manager. This is not doesn't have any packages for itself. Okay, like if you talk about Red Hat has RPM. Okay, where your actual packages and everything are managed. In between, what we use, yum. What is yum? Yum is not nothing but it's a, on top of it, it manages the packages. Along with packages, it also managing the dependencies. Okay, so that's why we use yum, apt get. There are others also, like RPM also can use for downloading packages. For Debian, we got Debian packages. So these are all tools. There are so many other tools, not just apt get. There are other tools also. But in Ubuntu, we stick with apt more to manage the packages, to install packages, to delete packages, to upgrade packages. We stick with apt. Okay.
Okay, got it. Thank you.
No problem. So while installing Docker, these are dependencies which we require. So I'm just going and installing these dependencies. Along with this, this is C. Again, I'm adding one more repo, guys. Now this is a repo which we are adding. So this is the key which we are adding, for a Docker key which we are adding. Why do we add keys? Anyone? Why do we add this key? This key got added onto my local. Now I will go and download this repo. Now this repo will get added. This, if you see this link, download.docker.com Bionic stable, this repository will get added to my local repo. So I got a local repo file in my system. This will get added to my local repo. Now this key, basically what we did, this key is for authorization. I've added this key, then I have added this repo, then I'm making sure that this repo which I have added, that is from the right source. So this key is authorizing and authenticating that the link which you have added, that is from the right source, not from any third party, not from any hacker or any middleware in between. This is from the right source what you have downloaded. Okay, that is so always whenever you download any software, you will see some sort of Google keys over there. So this is for authentication purpose. Okay, now I got this repo. Now in order to get this repo implemented in my local repo, again I need to run this command app update. Now when I run this command app update, you can see this is hitting this link also now, my local repo. If you see the hit 5, it is hitting the link. So that means it got added to my local repository. Now by just running one single command, I can have my Docker installed. Now this is all I have covered during the Linux session, guys, when we were doing packages. At that time when I was explaining what is apt, what is yum, what is repo and things like that. Okay, this is how it works. This is one way to download. There are other ways. You can download a tar file, unzip it, put it in the proper location, run the tar file. That is the other way of downloading. If you want to download it from the binaries, so there are n number of ways to download any package on Linux machine. This is the right way of doing the one which I did right now. The reason is upgrade and update becomes very easy. Why easy? Because your link, the Docker link became part of your local repo. Now using the apt command, you can manage everything. Using simple apt commands, you can manage the entire thing. Make sense? Anyone? Any question? Any doubt? Okay. Now, if I go and quick check Docker version. So I got this Docker version 23.04 build running right now. Okay, so I got Docker running. Now, if you want to see quick, if there's any Docker container running currently, so Docker PS, this will list all the running container. So if you see, there's no running container. Okay, Docker command. So these are Docker ad hoc commands which we are running through right now. Docker PS will give you list of containers which is running. And if you want to see list of container which got delete, exited, which is stopped, and all those, then you need to use a flag called docker ps-a. What do you need to use? You need to use a flag docker ps-a. Okay. Now, if you want to run any container, how do you run those containers? If you want to run any container, you can, like suppose you want to run a Nginx container, for example. Okay. How do you run that Nginx container? You can just simply do a docker run and followed by Nginx. So what it will do, it will go and fetch the latest Nginx image. Now what is image? Firstly, a docker image is nothing but it's a read-only template that contains a set of instruction for creating a container that can run on a docker platform. So it's nothing but it's a template what you write. Okay, the template will contain set of instructions, like you will be mentioning like what all things needs to be done when a container is created. Those instruction needs to be mentioned inside those file, and then you run a docker platform. So I'm not creating a docker image from scratch today. That is something we'll try to later. But yeah, there are pre-built images, like Nginx has its own images. Now if you see my container, I don't have any. If you want to list images, there's no images right now. It's completely blank. So the first thing what I can do, I can, if I want, I can pull image, docker pull. If I want an Nginx image, I can pull image with the command docker pull. So from where this will come, this pull, if I try to pull this, from where it will come? If you see, it's fetching the image. Now when I was talking about lightweight, I'll show you the lightweight means. Okay, now if you see, I got a Nginx latest image fetched From where did I got this? That is something we'll talk about later. For now, if you go and see image size, 142 MB, that's it. Imagine you're setting up image, like if I go and download Nginx from the Nginx official website, it is not less than 1 GB. And inside as an image, it is very lightweight if you want, because this is something needs to be deployed on Docker container. So this is very lightweight. Only the required thing which is there to run your Nginx image, only those things are captured. All additional things are removed and a lightweight image is created. So this is of about only 142 MB. That lightweight it is. Now, from where did we fetch this image? We fetch this image from the official website, Docker Hub. This is the official website, Docker Hub, from where we fetch the image. Okay, so this is the place where your public and private images can reside. Okay, Docker Hub is a nothing but it's a container registry wherein you can store your images. Now, which image did I fetch? If I go and look into Nginx over here, so this is the official Nginx image which I have downloaded. This is the one which we have downloaded by running the command docker pull, and this is how I got the latest. So there are multiple tags, guys, over here. If you want to have some specific image, this is the latest. Now, if you want stable Perl, this version. If you want stable blue eye Perl, all these are different version of Nginx. If you want this, then you just need to mention Nginx semicolon followed by the image name. Now, these are public repositories. These are public repositories where this official Nginx developers have created this image. They have uploaded it into a Docker Hub, and this is publicly available right now for us to use it. Same way, you can also have your own private repository created. On the Docker Hub itself, you can have your own private repository created, and you can have your images, images stored over here. That is something I'll talk about that later, because will do something like this. We'll have our own image created, custom image created, and not on Docker Hub, but yeah, we'll push it on ACR. That's Azure Container Registry. That is where we'll push our images. So now this is how your official images comes in picture. Same way, if you want Apache, suppose. Same way, if you want Apache, see, you got Apache also. You can go and install Apache also. Make sense? Okay. Now, now I have the image on my system. Now, if I want to create a container, Nginx container, very simple. I can simply do docker run Nginx. So this will now what it will do when I run this, execute this command, what it will do, it will go and check my local image, whether I have this Nginx image or not. If not, then it will again automatically it will connect to the Nginx container, and it will sorry, Docker Hub, and it will get me the image. Okay, now if you see this, I am running this container. Now if I open a new, it started the work. Nginx container running, started work process 28. Now this is, if I go and open a new shell, because this is on my screen right now. This is, if you see, this is completely on my screen right now, and it is taking up the complete terminal. When the container is running, it is taking up the complete terminal, and I cannot do anything now. If I do anything, the container will get stopped. So that's why I'm opening a new container. Okay, I'll quickly log into my VM. Now if I run the command docker ps, do you see a container running over here? the container ID, the image name, the command. What exactly is command? That is something I'll talk about later. For now, the command is running. When it was created, about a minute, up for a minute. Running on port 80. It is running on port 80. How do we check? Can I run the check with this command localhost, curl localhost, fail to connect to localhost port 80. Did we open port 80? I think we have opened, correct? It's there. And what is the problem? Connection refused. Okay, that's okay, no problem. Okay, so this is basically currently running in as a attached mode. So it's taking up the complete terminal, and as soon as if I close this terminal or if I do anything on this terminal, this container will get stopped. For example, see this. Okay, now if I go and run your docker ps command, your container got stopped because this was running in a attached mode. What do I mean by attached mode? Means it is running currently as a attached mode, and it will be whatever it's happening inside the container that will be displayed on the screen basically. Now this is not the right way of running any container, guys, in attached mode, because what will happen, it will be part of your screen, and as soon as you close that screen, that container will get stopped. Now it got stopped and you don't see anything now. If I go and do -a, then you can see that there was a container called nginx which got exited 40 seconds, 41 seconds ago. There was a container with -a. Okay, and if you want to delete this entirely, you can simply do it, docker delete, and you can just have the container ID. The first 3 digit is more than enough. Oh, sorry, RM. Okay, RM is to delete. Then the first three ID will remove the container. Now that was in attached mode which we are running. Now I'll show you the detached mode. So detached mode will basically, it will run in the backend and it will run as a container process. Okay. Now the same command, docker run nginx, this is the same command which we have executed earlier. The only difference is I'll have a flag called -d. This is basically I'm running a container in a detached mode. Okay. Now if you see this, I'll have this container running in a detached mode. Now if you want to still, now you want to say like, you say like, I want to see the logs, what's happening inside the container, because in that attached mode it was displaying the logs. I can't see the logs. No problem. Docker logs followed by the container ID. You can have the first 3-4 digit numbers, guys. See, you can see the logs. This is how your containers will be working. Okay. Now you can see the logs. You can inspect your container if you want to. So this is how you will debug. Like whenever you get questions in interview that my container is not working, I have no, I don't know what's happening. So the first thing is checking Docker logs, container logs. Second, you can even inspect your Docker container. Inspect basically gives all the information regarding your container. What kind of IP it is using, what kind of port it is exposed to, what kind of binding it is using, what are the gateways, what is the OS, what is the image, everything, where it is mounted, everything it is doing. All this information you get in inspect. So everything related to your container, go get those information inside the inspect mode. Make sense? Anyone, any question, doubt till now? We spoke about how do we list containers. We spoke about, now if you want to stop container, for example, this is running container, correct? If you want to just stop, not delete it. Okay, so basically you can just do stop 919. Done. So it will not show in this PS, but it will definitely show in -A. Now, if you want to have the container started again, start 919. That will show in PS also. See this. Make sense? Created 2 minutes ago, status 4 seconds ago. Okay. Now let me delete this container again. So you cannot direct do a RM, guys. You need to stop the container first, then you can do a RM. Okay. So this is what we had created an Nginx container. Now, if you want to Nginx container, so on a container level that listens on port 80, Nginx by default listens on port 80. But if you want to expose that on some other port, like if you want to access it from outside world on port 5000, just imagine you want to access your Nginx web app on port 5000. So you need to expose that port on your container. Okay. So basically what do I mean? This is your VM. Inside this VM, you got your container, Nginx container, which listens on inside internally, it listens on port 80. Now outside world, you are somewhere over here. You want to access your container. So the request will go on. You want to send this request on port 5000. This is a custom port. So 80, like if you expose port 80, that has security issues because that's a common code, common port, and hackers can easily trace your route and things like that will happen. So I just want the 5000 port to be open at the container level so that my request will be sent on port 5000 and it will receive on port 5000 itself. This is how you can go and expose port 5000 for your container. How this is done? This can be easily done with the command docker run -d detach mode -p 5000. This is on which I want to access the application, and 80, this is on the container. Port 80 will get exposed on the container. Okay. 5000 on which I will be accessing the application, and Nginx, the image name. If you want to give a container separate container name, you can give it by this flag -- name. That's up to you. Okay. Docker ps. Now do you see this? We can access this now on port 5000. I need to expose this port 5000, guys, before I go and access. Let's go to your VM. Let's go to networking. Let's go to add inbound rule. Let's open the port 5000. Let's name it as Nginx port. Okay. So we have created a port 5000 and we are exposing Nginx, which is running inside the container on port 5000, so that we can access that from outside world. Done. Let's do curl localhost 5000. Do you see the page? Welcome to Nginx. Now we are able to access the web server. I can access this from outside world also. HTTP welcome to Nginx. Okay, this is how you will be exposing the ports. Anyone and any question, any doubt, guys, till now? Whatever we did. These are very simple basic commands which we are executing for running simple Docker containers. Are we good till here? Anyone? Any doubt, guys? No doubt. Okay. Now this is your Nginx. Now imagine you have done some changes to your Nginx. Okay. You have added some configuration to it. You have done some changes. Okay. Now somehow the container got stopped. So by default, Nginx volume is not persistent. Like suppose if I go and delete this, stop this container. Okay. I've stopped and I'll just remove this container also. Gone. There's nothing anywhere. Okay. There's nothing anywhere now. Gone. Now, what if you have added some configuration? What if you have added something very important to that particular container? So by default, the container volume is not persistent. So if your container stops, if you have any data on it, it gets removed. So by default, this is not persistent. You need to go and make that particular volume persistent. How do you do it? That is done using mount. You can do a volume mapping. Okay, so you can do a local volume mapping. You can do a cloud volume mapping if you want to map your volume to somewhere in Azure storage or S3 or local hard drive. You can do it. So we'll see how do we mount the volume using local hard drives. So whatever storage we have. So let's create a location where I will mount mkdir opt, name it as Nginx. Okay, so this is how I'll be mounting. So this is the location where I have created. So in this location, whatever data I put in, that data will get replicated automatically on the container. That is what we want. So I'll create again docker run -v. -v, it's for volume mapping, guys. So keep that in mind. Now, what was the location we had? opt nginx semicolon. Which location on the container you want to mount? Now I want to mount where I keep the static files, that location, because I'll be adding static files to my Nginx application. So the static files are kept in usr share nginx html. This is the location where your html files are kept in Nginx basically. Okay, so I'm just having this. Then I'm exposing the port 5000 again, is the same thing. If you want to expose port 80 from outside world also, you can do this way. Okay, you can do this way, but let's do 80 only. Okay, last time we did 5000, this time I'm doing 80. And detach mode Nginx. Now there are three things I'm doing over here. First, I'm running a Nginx web server as a container. Second, I'm mounting a volume. So I have a local drive, local folder created opt nginx, which I'm mounting on the container user share nginx html. So whatever I put in this particular folder, that will be reflecting over here also. That will get replicated at this location. This location is inside container, guys. This location is inside container when your container will work. Okay. And then we are exposing the port 8080. 80 is to access the application from outside, and this 80 is getting exposed on the, so the request will come on 80 and the response will also go on 80. Where were we? So the request is also coming on 80 and the response is also going on 80. So this is what the command it is. So we are making sure that the volume is persistent. Tomorrow, if I delete this container, which is getting about to get created, my data should not be removed. See this done. If I go and do a docker ps, I have this listening on port 80. That's the one thing. And even my volume is mounted. How do you know the volume is mounted or not? You can do a docker inspect and you can look for volume mount. Wait, let me look for the mount. See this? The mount over here. Where it went? Do you see this? The type is bind. We have done a bind. What is a local? This is the source on my local hard drive, and on where exactly it is mounted, user share nginx html. Let me show you one thing. Now I go to the location opt nginx. Okay, we are in the location. There's no file over here. Now I'll go and add a index.html file. Now I'll go and quickly add a file, html welcome to nginx.
Means if we delete the Docker image, then only means after that we can able to access the application or any content on that image.
Yeah, you, not application, because your docker container is stopped, then application will not be accessible, but the data will be accessible. You will still have the data. Your volume will still remain. So this index.html file is my data. It's my static file. Imagine it's a static file. I have got around 100 static file which on which my container is running. Okay. So I got the static file on my local hard drive. Now, because of some XYZ reason, the container has stopped and got deleted automatically. Your data is still there in your local hard drive. You can still launch a new container quickly with this data. Okay. Now let's go and
So
test.
how do we get that? Means that
Sorry.
means to run the Nginx, so we require some supporting file to run that Nginx setup. So how we get that Nginx supporting file? Means here we only, you say we have only the index file.
Okay. So this is an example. This is, if you see now, if I run this command, like if I run this nginx http, see what I'm getting. Welcome to nginx. Am I getting the default nginx page now? This is how I'm getting. Did I add any index file on the container? So the answer is no. Where did I add everything? I'm adding inside opt nginx, which is on my local drive. Correct. This is somewhere on opt nginx. Now answering to your question, that how do you set some other configuration? Now in reality, you will have some location on your container wherein you will map that location to your local drive or cloud, wherever you want to map it, and you will put all your configuration over there, and that way you will configure your nginx to read all the configuration from that location. So you need to go and change the config file of nginx, update those config file, and make sure it is reading the file from this particular location. Like suppose I mapped this to user share html. That is the location which I have mapped to. Now if I put any configuration over there, and if my nginx config file is reading the configuration from that location, it will go and make changes. Now this is a simple example wherein I have replaced the default index.html page what Nginx is reading with my own page. See this. And if I go and delete this, do you think my opt Nginx file will get deleted? If I stop this container, for example, if I go and just stop this container and just forget about stopping, I'll just remove it also. Now, what do you think? We'll have, do we have the index.html file, the custom file which I've created, or even that will be removed? What do you guys think?
It's remain on that
It will.
local drive.
Correct. So that is what we call as persistent volume. Now, if you see, I still have this index.html file. I can now easily go and run the same command again. I can go and run the same docker run command again. See, this is the command, and I'll have the Nginx container running again without any issue. See, done, done. Welcome to Nginx. This is what persistent volume means. Persistent volume will make sure whatever configuration. So this is just an example of static application. Same way, there is no hard and fast rule that you can have only one volume mounted. If you want to have 10 volume mounted, wherein if one place you're keeping a static file, second place you're keeping a dynamic file, third place you're keeping an Nginx configuration, fourth place you're doing some database mapping. So it's up to you how you are doing a setup. This is the same way you will follow to get all those things mapped to your particular containers. Okay, make sense? So this is a classic example how you do the volume mounting in Docker. Now, if you don't use this, there are default locations also wherein you can go and mount. So this is, I'm using not a default location, but a custom location where I am using my own custom location where I am mounting the things. Okay. If you just do a mount, it can go to the default location also. Any questions till now, guys? Anyone, any questions? Do let me know.
Yeah, means you are deleted the Docker, but you still accessing the Nginx. So means what is the use of then Docker? Means you are accessing the Nginx from the local system itself after the deleting the Docker.
Mhm.
Sorry, means I am just confused.
Yeah, could you please repeat yourself again?
Means you are deleted the Docker image, and after that
Mhm.
you are still accessing the Nginx HTML page. So where is the Nginx that HTML page actually located? It's on the Docker image or it's on that your local system?
Okay, I have deleted, but if you see, I have again created the container over here.
Okay, but it's a different ID, means created with a different
Correct.
ID.
But if you see, I got this index.html file on this location. That's my local hard drive on my system, correct? And I'm mapping this location with this location. This location is nothing but the location where index.html file should reside in Nginx. If you go and learn about Nginx, so this is the location where your index.html file should reside. So index.html file is actually there in this location. Now, because I'm doing mount, what do I mean by mount? Mapping the volume. I'm mounting the volume location on my hard drive with the container volume. So whatever I put in this location now, if I put any files over here, not just index.html, any files over here that get mapped with this location. So this file will be visible. This particular file which you have over here will be visible over here also. This particular file will be visible over inside the container also. Okay. Now, if you want to know, if you want to log in inside the container, I'll show you that also. Wait. So this is my container. There's a command docker exe execute followed by the container ID, and then you can run the command like ls. What is the location? User share nginx html. Now, do you see where exactly I'm running this command? I'm running this command inside the container, guys. This is how, if you want to run something, like want to know, you cannot log into the container basically, but if you want to know, execute something inside the container directly. Now this is the command I'm running directly inside the container. You see this index.html file, from where it got the index.html file? Did we add or create anything? No. This is getting mapped because I have the volume mapping done, and I have this file on my local basically over here. Do you see this index.html? If I delete this file, the file will be removed from your Nginx also. So this is what volume mapping means. When you bind your volume, because container, by default, container volumes are not persistent. What do I mean by persistent? That if you make any changes to your container, and if the container stops, the changes will be removed permanently. You will not get any data out of it. With persistent volume, you're storing your configuration in a different location, in a separate isolated location. If anything happens to your container, this container stops, it is not running, not responding, you can easily create a new container quickly with your persistent volume, because you already have the data. That is what I did. I stopped the volume, stopped the container. I created a new container with the same index.html file. Make sense?
Uh, means if we not do the mapping, then
Mhm.
after deleting the image, then we can't find that file on our local system. Means it's
Yes,
yeah, okay.
absolutely on the point now. If you don't do persistent volume and post that, if the container stops, nothing you'll get. Okay, any questions, any doubt with volume mapping and things like that? No questions, guys?
So it's a mandatory steps for means while creating the image for the Docker, so map that mapping.
Yes, it is mandatory. Volume mapping, network port mapping, all these are mandatory steps. Without this, even if you create a container, that will not make any sense. It will not be accepted by your company, their team. So they will say, no, go do volume mapping, map it, because this is a part of your architecture. When you design an architecture, like I want my microservice application to be deployed on containers, on Docker. Now they will decide where the volume mapping should happen, either on the local hard drive. Local hard drive very rare, because if your VM gets deleted, correct? What if your VM storage is full? So we do volume mapping on cloud, somewhere on Azure storage, blob, or on S3 and things like that we do. Or if we have our own network SAN hard drives where we can connect to. So that at those locations we do volume mapping. So initially all the configuration, when you run something in a container, you have a custom image created. That is something we'll do tomorrow. In tomorrow's session, I'll show you how do we create custom image, because as if now I'm just getting the image directly from Docker Hub. That's a traditional image which that is the image which I'm getting from the public repository. Tomorrow we'll create our own private repository. We'll have a custom image created. We'll do the volume mapping, and we'll put the configuration, and we'll run the Docker container, that container will contain only my application, my custom application it will run. So that is something we'll do tomorrow. But today this was completely basic, guys. How do we execute container? How do we create container? How do we fetch image? How do we delete container? How do we go inside the container? Like if you want to execute something inside the container. So the ls command which I executed, that was inside the container. All these are very basic. Okay. So make sure, how do we do port mapping? How do we do volume mapping? This is two important things what we did. What is Docker attach? What is Docker detach? Okay. Tomorrow we'll focus on Docker file. We'll focus on command. We'll focus on entry points. We'll have our own custom .NET application. Remember the day where when we created the .NET application, I'll be using the same .NET application, and that application will be deployed on container now. We have deployed on Azure Web App. Now I'll be deploying that on container. Make sense? That is what we'll do coming forward. So if anyone has any question, any doubt, please do let me know. I'll be sharing my notes of whatever commands I've executed. I'll be sharing those notes with you guys. Make sure to go and run those notes by yourself and try each and everything, because after Docker, we'll be starting with Kubernetes, which is very bigger tool than this one. Okay. So make sure there's no go back, create a VM, setup. Everything is given in my notes, guys. Whatever I've said is there in these notes. You just need to go and follow the exact same step by step, and you'll be able to launch your containers. Then after that, once you're comfortable launching containers, start do R&D. I have pulled Nginx image. You pull Apache. You pull MySQL DB. You pull something else. So try because without R&D, it's not possible for me to cover everything. Okay. So you do your R&D. If there's any issue, let me know. Okay. Anyone, any question last minute check? Any question, guys? Any doubt? Because I see very less response from you guys. So I'll have to ask so many times. Anyone? No one? Then thank you very much. Let's meet tomorrow and let's continue with this Docker topic. Bye bye.